Hello, welcome back. Let's continue with our lesson. Before we continue, let's look at the summary questions. And of course, you can see the summary questions are very easily, and I believe you might have done it, okay? Good. As you can see, it's very easily. You can arrange them in that order. Big Bang, then come to the formation of the solar system, the dinosaurs, of course, before the living things. Good. And then over here, if you compare the age, the age is what between the age, you can see this is what the 4 billion against 14 billion against 4 billion. Then you come to the description, okay? The sudden expansion of the universe. This is talking about what? The Big Bang. And then here you have to draw a scale of timeline, which I know you can also what to do. So if you read this portion, you can easily get the drift. Good. So let's continue with our lesson. We go to the next, space and satellite. Space and satellite. Of course, as usual, let's look at our objectives. To describe how to get a satellite into orbit, and then describe some uses of what satellite. Good. So this is our objective as far as this one is concerned. So let's look at the into space. So basically what we are saying over here, how does a rocket get into the space? How does a rocket get into? So we give an example. Like you take a balloon, okay? You take a balloon, you fill it with air, it will fly into the atmosphere. What allows it to fly? It is by courtesy the force. So the force of the balloon on the air pushes the air backwards. So the balloon will fly, okay? And we are saying this is a bit like how scientists put a satellite into what? Orbit. Okay? The force of the air of the balloon pushes the balloon forward. And this is how scientists put a satellite into orbit. So basically, if you are looking at this one, we are saying how does a rocket get into the atmosphere? What pushes the rocket? Okay? What pushes the rocket? This is how we are giving the description. So he said they launch a satellite by attaching it to a rocket. Okay? Fuel burns inside the rocket and pushes the waste gases out of the bottom of it. This push is one of the part of an interaction pair. There is the force of the rocket on the gases, and then the force of the gases on the rocket. There are also forces between the rocket and then the air. Now, when the force of the air on the rocket is bigger than the force of the air on the rocket, it will then take off. Okay? And this is the description. You see, you could see the various forces. This is the force of the air on the rocket, and then this is the force of the gases on the rocket, and then the force of the rocket on the gases, and of course, the force of the rocket on the earth. So this is what usually pushes. So you can see the gas over here that we are talking about, okay? And you've seen how, I think it's not the first time you've ever seen how a rocket is released into the atmosphere. Good. So this is how it is what it is usually released. Okay? Good. Now if you come to this portion, into the orbit, okay? Into the orbit, for instance. So over here, if you read over here, it is what it's about what the mission of the moon. Okay, the mission of the moon. He said there have been more missions into the moon than other objects beyond the earth. That is because the moon is the closest object, and it only takes days to get there and back. There have been missions to all the planets in the solar system, and then the sun. Okay, and then so he said the New Horizon spacecraft will take a picture. Also, this is about how taking the pictures, you know, all this kind of stuff into the space. Okay, so this is about those ones. Now let's look at, this is where I'm very, very much interested. Into the what? Into the orbit. Okay, because we have to describe how the satellites get into the orbit. So let's see. The moon is only natural satellite of the earth. The first artificial satellite was what? Sputnik 1, and it was launched by a Russian in 1957. It was a metal sphere about 50 centimeters in diameter. Now, to get into the orbit, this is where my interest is. The engineers needed to launch it to the right height and fire it at the right speed. The force of the gravity kept it on orbit. So this is how the satellite is kept on what? Orbit. After it has been released, okay, after it has been launched at the right height, the fire, and then the fire it at the what? At the right speed, and then the gravity will keep it on orbit. So this is it. Then let's look at over here the use of satellite. The use of satellite is what I've underlined for communication, for monitoring weather, okay, for monitoring weather, for studying the earth and space and all those. So this is what I've underlined. Then you can see this is where you have the uses of what? Satellite. So you can see use of satellite. So this area you can find the use of what? Satellite. Good. And then we go on. In the same place, when we talk of in the same place, it means we have some satellite, they are stationary in the space. They are stationary in the space, okay? When they are launched, they are made in such a way that they can stand in a space. And this type of satellite, we call them a geostationary orbit, okay? Geostationary orbit. You can see a picture over there very clearly, okay? You can see a picture very clearly. So we are saying, some satellites stay over the same position on the Earth all the time, and they are what? They are in a geostationary what? Orbit. It takes 1 day for a geostationary satellite to orbit the space, or the Earth, sorry. Now, it is always above a spot on the equator. A geostationary satellite is about what? 36,000 kilometers from the Earth, okay? Take note of that. A satellite in a geostationary orbit can also broadcast television signals. A television company transmits a radio signals to the satellite, and then the satellite broadcasts it to a lot of other houses. Now, if you walk down the streets, you will see that all the satellite dishes point in the same direction. So basically, this is what we remember. So the televisions we are watching, all those kind of stuff, it is by courtesy geostationary what? Satellite, okay? Good. So this is it about the satellite, which you know. I don't think this is something new to you. And we also have what we call the lower orbits, okay? The lower orbit. What are these lower orbits? The lower orbits, which we also call the LEO. So there are a lot of satellites, such as the International Space Station, and they are what? Low Earth orbit. This is an orbit below 1,000 kilometers from the Earth, okay? Good. Some LEO satellites go over the North Pole and then the South Pole in a polar orbit. So what are these polar orbits? What are they used for? The polar orbit satellites are useful for mapping, okay? And then you also need a satellite in LEO if you want to see the whole of what? The Earth surface. So basically, they are used for what? For Earth surface. If you want to see the Earth surface, you can also use that one. And then also for what? For mapping. This is the use of what? The polar orbit. So please take note of that. And you can see the picture over there. We have the polar orbit over here. And then these are the polar axes. And this is the geostationary. You can see it. And then we have the low Earth orbit also over here. So the picture states all these things very clearly, okay? Good. So this is basically as far as the space and satellite is also concerned. It's not anything so difficult, okay? All these things, you've done some of them back in grade 6. If you go and look at your grade 6 science book, you can reconcile and then you can see most of these things. They are not new, okay? It is just a build-up from what we have learned in previous days, okay? Good. And please don't forget to look at what the summary questions. It is also very simple for you to do. Okay, good. So we shall stop here, and then inshallah we shall continue another time. And I wish you all the best. Have a nice day.